Right, this is my new microwave oven transformer setup. What we have, because I blew a breaker on the last one, I've now ballasted it with a 2 kilowatt electric kettle, which is full of water, connected to 2 wires. I haven't bothered with the earth because the surges could cause the element to break down, which would trip the main RCD for the house, which could be quite dangerous. So what I have done, the current comes in through an ammeter, which is actually, there's a current transformer on the back there, through the kettle, into the transformer, out of the transformer and back to the mains. The secondary of the transformer, this big thick blue wire here, is the ground, which is connected to my chicken stick here. This is the high tension electrode. The arcs at the moment are not too spectacular, but that's how we want to start. I have a visible break here as well, with a switch in line, and also the kettle switch breaks the circuit as well. So I have several points where the circuit can be broken. So without further ado, check. This is live. That switch is now on, so it's live up to here. And I don't know whether you can hear that, the transformer's humming. We have about 1.2 amps current through the transformer, not a lot. And as I said, the arcs are not too spectacular right now, but you notice the arc starts off blue and becomes green. You see how much energy is being dissipated in that arc. It's enough to melt the copper wire. Now next, first of all, safety first with these. Everything off. Visual brake there. Visual brake there. Then, and this is going to be bizarre, the hot piece of metal I dump into the cold water. I will be right back with another video. I'm going to try to connect a series capacitor, and we'll see how that goes. Right, welcome back. The setup now is exactly the same on the primary side. All the wiring remains the same, totally undisturbed. The only addition is this section here, which is the high voltage capacitor from the microwave oven, which is now in series with the secondary. It's rated for 2100 volts AC, so it should be quite safe. It has a discharge resistor which is functioning, but I have a meter that's capable of reading 3000 volts anyway, so I can check it for safety. Although safety is, of course, with a setup like this, a bit of a relative term. But this is just, to me, interesting. The sparks apparently are quite a lot more vicious when you're using... The system is not hot yet, so don't worry. Yeah, it's quite a lot more vicious sparks, apparently, so I'm now making the brake. The visible brake in the system's gone. The main switch is now on. Transformer is hot. Well, I wouldn't call that much more vicious. Probably not enough capacitance to form a resonant circuit. You probably can't see, but the arc is quite significantly longer. And this does get very hot. Let me show you. If I arc to somewhere around the middle, I can melt the wire off. That's a 2.5mm copper wire. Now that is what I call an arc. Right, I am now going, you can see my chicken sticks just caught fire. So I'm now going to end the experiment and call it a success. Thank you very much.